Alright, now let us understand these concepts by doing some examples. Okay, so first example I choose is a bucket of water uh, bucket of water that spins, that means a bucket of water that I tied in my wall, which spins with an which is which spins with an angular velocity omega. Okay, this is the picture, okay, that I remember. This is the bucket have some water and which is tied on my wall, and it spins in the anti-clockwise direction, and that's the direction, that is the z is the, that means the z direction is the direction of angular velocity. What I want to know is, when it spins, what should be the shape of the surface of water inside the bucket. Okay, what should be the shape of the surface of water inside the bucket. Okay, trivially we know what happens when it rotates. Okay, you know, its shape will be, that we all know. If you are interested, you can do this experiment having a water. I have done is the water, and you just rotate it, you can see how the water surface will behave. Okay, let us mathematically calculate this, you know. So for that I need the force diagram. I am considering the situation at equilibrium. At equilibrium means the forces are balanced. Okay, so which are the forces here? The forces, probably the contact force. I think you remember what is contact force. Contact force arises due to the molecular or atomic interactions, right? Okay, here it comes. So this is the force diagram. So at equilibrium, so this is the omega, and see this small one, this you know, this is the surface, the slanted surface of water, and I choose this small mass of water. So W is the weight, and F0, that's the contact force. F0 is will be in this direction. This is F0, and since it is a rotating frame, there is fictitious force. Okay, this is the force diagram. Is it clear? Omega in the z direction, and a small mass element I consider, and W is the weight, and F0 is the contact force, and F fictitious is the fictitious force since it is in the rotating frame. So I little more corrected it. So this is a corrected one. So F0 have two components, F0 cos phi and F0 sin phi. I have taken phi as the angle between the normal and the F0. Okay, this one is the surface of the water. Okay, so here I assume the surface is little slanted. Okay, mg is the weight, so this is phi, and m omega square r is the fictitious force. So omega is actually theta dot square is omega square. Okay, so how should be the equation? F0 cos phi, so the upper side is positive, this side is positive, this side is positive, and this is negative, this is negative. So F0 cos phi minus mg equal to 0, first equation, and minus F0 sin phi plus m omega square r equal to 0. That are the two equations. Okay, that I have written here. F0 cos phi minus w equal to 0 minus F0 sin phi plus f fictitious equal to 0. That are written like this: F0 cos phi minus mg equal to 0 minus F0 sin phi plus m omega square r equal to 0. By simply doing the calculation, and the calculation is, I have taken F0 cos phi is equal to mg, and F0 sin phi is equal to m omega square r. Just divide the second by 1, so I will get F0 will cancel, sin phi by cos phi is tan phi is equal to omega square r by g. That is what I get. Okay, now I am going to, what I required the surface, the equation of the surface. So z is the direction, so I like that. This is the z direction, and this is the radial direction r is this one, this direction, the increasing radius of the water, you know. So this is r, so this is the water surface, this one. So you know, this is the normal, and this F0, and the angle is phi. Therefore this is the normal and this is the tangent. So this angle will be phi. This angle will also be phi. So the slope dz by dr. dz by dr is, we know that is a different. Dz by dr is actually equal to tan phi, that we have learned in first semester. Dz by dr is equal to tan phi. So that I have written here, dz by dr is equal to tan phi. But tan phi is omega square r by g. Okay. So dz by dr is equal to omega square by r by g, that we got. So what is the equation of surface? Equation of surface is z is equal to f of r. That is the equation of surface that I want. So what I want is, I required z from this equation. So what I want to do, I just want to integrate. So integral dz is equal to omega square by g into integral r dr. So integral of r dr is r square by 2. So this is half omega square g by r square. It is well. Therefore z is equal to half omega square by g into r square is the equation is the result we obtained. So what it means? It is really true. It is an equation for a parabola. So y square is equal to 4s is the general equation for a parabola. From that we can understand it is the surface is a paraboloid of revolution. Okay, that is the answer. So the water in the bucket will be like that. The center is tilted down and the shape of a parabola. Just what you are seeing is an open umbrella in the downward direction, like that. All right, that was a good example.